Welcome to this session called Infra Infiltrated Yes, PII Exfiltrated No. Before we begin, I'd like to show you a short but hopefully powerful demonstration of how easily an attacker could gain access to sensitive information within your infrastructure. Please pay close attention. Imagine we are hackers and our target is a financial institution called Financial First. We're going to target their front-end web page with a login form to gather some information. As with any attack, the first step is to always gain some information about as much information as possible about the target so that you can identify potential attack vectors, which include the backend server, the front end, the database, and anything in between that might be related to the service that could give us some clues on how to gain unauthorized access. Let's head on over to our target's webpage, financialfirst.com. And from there, let's go check in the login page and see if we can learn about the requests that are being made to some backend. Let's open up the inspector and make a request by logging in with some dummy credentials. We just want to see what the network tab will show. And we see that a request is being made to some endpoint/API/login at a coincidentally the same domain as wherever the front end is being served from. And now with the domain name in hand, let's perform an NS lookup to find the IP address of this server. And we can see that it's 10.211.55.8. Okay, so we're making great progress here. Let's explore some potential vulnerabilities that the server's infrastructure may have. We can start by looking for open ports. And to do this, we can launch an Nmap scan against the server, probing for open ports on the machine. Let's spin up my instance of Kali Linux. If you haven't used Kali before, Kali Linux is a Debian-derived Linux distribution designed for digital forensics and penetration testing. Now that we're booted into Kali, let's kick open a terminal and issue the following command: sudo nmap-p-10.211.55.8. Nmap is a popular open source tool for network exploration and security auditing. The -p- flag instructs Nmap to scan through all ports from 1 through 65535 at the address 10.211.55.8, which is the target IP address we discovered moments ago. Disclaimer. Before I execute this command, I just wanted to say that using tools like Nmap to scan servers or networks without the explicit permission of the owner may be illegal in certain jurisdictions. Unauthorized use of Nmap or other similar tools could result in criminal charges or other legal consequences. Please ensure that you have the necessary permissions and that you adhere to the applicable laws and regulations before attempting any kind of network scanning activity. The demonstration in this video is for educational purposes only and should not be replicated without the explicit permission and authorization. Okay, let's keep going. The Nmap results reveal several open ports, including the typical Postgres database port, SSH port, and of course HTTP and HTTPS. So we have some information on hand now which could be used as potential attack vectors for us. And who knows what other vulnerabilities that this service may have from not being fully updated or having some other unsafe server configuration. The easiest thing that we can do at this point is to attempt various username and password combinations. According to an article published on Zipia in 2023, 80% of hacking breaches are related to some password issue. This shocking statistic doesn't just end here. 59% of Americans use their name or birthday in their password. And here's another shocker. 57% of people who have been a victim of a phishing attack still have not changed their password. So, knowing this, I have here a basic script that iterates over the most used username and password combinations and attempts to log into the SSH service and Postgres database. The username and password list just came from a Git repository I found online, and it has hundreds and hundreds of common usernames and passwords. This script will run through an n-squared operation, attempting all passwords with every username, creating all sorts of combinations, and if there's a successful attempt with any combination pair, The script will print out what service, SSH or Postgres, and what username and password pair was used to allow us into the service. The script will then quit. All right, we got a hit on the database with username and password combination Postgres, password 2023. You've got to be kidding me. Let's create a connection in a new terminal window and see what databases are accessible to us. Great, it looks like we have access to the primary database. And what tables do we have access to? Aha! There's a table here called Credit Report. Let's see if we can get in and do a select star on this table to see if we can find anything of interest. Well, this looks like it's a ton of sensitive PII for a host of individuals across the platform with information such as their names, addresses, social security numbers, and more. My HashiTalks friends, as you just witnessed, it only took a few simple steps to breach the security of this financial institution and expose tons of sensitive information. In fact, this is basically what happened to Equifax in 2017, where their database was breached due to a bad username and password combination that were not particularly set too well. You can do some research and find out some more information about it, but the gist is that the database of approximately 147 million people, which included social security numbers, names, addresses, and tons of other information, were breached and exposed to the world. You don't want to be in this situation as a developer. But before we proceed, I want to assure you that this demonstration that you just witnessed was entirely fictitious. No real data breaches occurred, and all information displayed was of made-up individuals for the purpose of this demonstration. However, it does serve to illustrate the potential ease with which an attacker could gain access to sensitive information if proper security measures are not in place. It's important to note that the demonstration was a simplified version of what a hacking attempt might look like. It's designed entirely for the sake of brevity and clarity. In reality, hacking attempts can be far more sophisticated and complex, involving multiple steps and many advanced techniques to infiltrate a target's system. This only underscores the need for a strong infrastructure and a comprehensive security posture to protect and reduce the risk against such threats. All right. With this out of the way, let's get into 7 steps you can take to reduce the risk of a data breach. And some of these are more obvious tips, while others will take a bit more time for us to fully explain and talk through. At the end, we'll look at how a data privacy vault can help you achieve your goals, ensuring that your organization's sensitive data remains safe and secure. The first thing that you can do is make sure you have a very good understanding of the data that you're currently collecting or intend to be collecting in your project. PII, or personally identifiable information, is any data that can be used to identify a specific individual. Examples of PII include name and addresses, phone numbers, email addresses, social security numbers, driver's license numbers, and passport numbers. Identifying and classifying PII stored in your database is a critical step in improving your security posture because it enables you to understand the types of sensitive data you're storing and where it is located. This information can then be used to apply appropriate security controls, such as access controls and encryption, to protect the data from unauthorized access, use, or disclosure. By understanding the data flow within your system and where PII is being used or exposed, you can also identify potential vulnerabilities or weak points in your system that could be exploited by hackers. For example, if PII is being transmitted or stored in an unencrypted format, it is at risk of being intercepted or accessed by unauthorized parties. We're going to go into this in more detail shortly, but by implementing appropriate security measures, such as encrypting PII during transmission and at rest, restricting access to sensitive data, and regularly monitoring your system for unauthorized access or unusual activity, you can reduce the risk of data breaches and protect your organization's reputation and financial well-being. The second step you can take is to identify whether the information you're collecting is really needed for your business function. If you don't really need it, why collect it in the first place? Or if you don't need it anymore, why keep it around? Data minimization is the practice of collecting and storing only the minimum amount of data necessary to achieve a specific purpose. This helps to reduce the risk of a data breach and other security incidents by limiting the amount of data, of personally identifiable information, that your organization collects and stores. So why is data minimization important for security? Well, there are several benefits. First, by minimizing the amount of PII you collect and store, you can reduce the risk of a data breach. Secondly, it can help comply with data protection laws and regulations, such as the European Union's General Data Protection Regulation, or more commonly referred to as GDPR. Finally, it can enhance your privacy protection and help you build trust with your customers. So now, let's look at some real-world examples of companies that have implemented data minimization practices. And one of these companies is Google. Back in 2019, Google introduced a new feature called Auto Delete for its users' location history and web activity data. This feature allows users to automatically delete their data after a set period of time, such as every 3 or 18 months. So how can you implement data minimization in your own organization? Here are some best practices to follow. It starts off with data classification, as per our previous point of discussion. Identify the types of PII your organization collects and stores. Determine the minimum amount of data needed to achieve your organization's goals. Implement policies and procedures to ensure that data collected and stored is only needed and only used for as long as necessary. Regularly review and update your data minimization practices to ensure compliance with data protection laws and other regulations. As we know, code changes are inevitable in the world of software development. Sometimes we run into bugs that just need to be fixed, or new product requirements force developers to introduce new code or new dependencies. Believe it or not, code changes can introduce swaths of risk that can impact your security posture, that may impact how you ensure privacy of your data and your customers. Some things you want to keep in mind whenever you introduce a code change. Insufficient testing can lead to unintended side effects and create security loopholes. If you're touching a part of the stack that interacts with some kind of secure data source, it's best to have others look over your change, and if you have security specialists on your team to evaluate these changes and why they must really be made, then definitely include them in the discussion and the review process as well. Human error is more often than not the cause for many data breaches and security vulnerabilities. New bugs or misconfigured settings all can potentially expose sensitive data or create weaknesses for attackers to exploit. Emphasize a culture of code review within your organizations and ensure code changes are adequately reviewed by peers and security experts. Be mindful of introducing new libraries or dependencies, as they all can carry their own vulnerabilities, which may result in your application inheriting the vulnerability too. As complexity increases and your codebase grows in size, it becomes increasingly challenging to maintain and secure. Try to keep things as simple as possible for as long as possible. This one is painstakingly obvious, but it's always good to call out: don't ever commit any API keys of any sort to any source control, ever. You should be using tools like HashiCorp Vault to secure your secrets, for example. And if you're not familiar with Vault, it's a secrets management tool designed to securely store and tightly control access to sensitive data such as API keys, passwords, tokens, and certificates. So how bad can a code change mess things up? In 2020, the SolarWinds attack was a high-profile, sophisticated hack that affected many US government agencies and many more private companies. The attackers inserted a backdoor into the SolarWinds Orion software, which was distributed to thousands of customers. The breach was a result of malicious code change that went undetected, allowing attackers to gain access, of course in an unauthorized manner, to sensitive data and systems wherever Orion was distributed to. Finally, in 2022, SolarWinds agreed to pay $26 million in settlement against the class action lawsuit. Staying on top of code changes can help maintain privacy for users, reduce risk of change, and reduce the possibility of insane data breaches like this. Data encryption is a critical aspect of data security, as it helps protect sensitive information from unauthorized access and potential data breaches. It involves converting plain text data into ciphertext, which can only be decrypted by those possessing the appropriate decryption key. If you're dealing with sensitive data which you think might be detrimental if ever leaked, just encrypt it. Oftentimes, you may be required to encrypt some data to comply with industry regulations such as HIPAA, GDPR, or PCI DSS. Other times, you may be doing it to protect intellectual property, ensure customer trust, or prevent unauthorized access in general. Improving access controls is a crucial part of enhancing data privacy and strengthening your security posture. This topic of access controls is a big one that goes well beyond the scope of software access to data. It can technically be part of how users access an application and have access to data and what they can do to mitigate risk as well. Access controls determine who can access specific resources and what actions they can perform, thereby helping prevent unauthorized access and reduce the likelihood of a data breach. Here are some things you can do to keep in mind as you approach access to data within your systems. Implement the principle of least privilege access. Grant users and applications the minimum level of access necessary to perform their tasks. Introduce a regular review process and update permissions to ensure that they align with changing roles and responsibilities. Use role-based access control, or RBAC. Role-based access control assigns permissions to roles rather than individual users. This simplifies access management and makes it easier to enforce the principle of least privilege. For example, the front desk receptionist at the doctor's office doesn't need to have access to every detail about my profile that my doctor would have access to. There's basically no reason they should have my full date of birth or entire medical history. On the flip side, it's understandable why the doctor is going to need it. Making some infrastructural changes to your application is not for the faint of heart, and it could be quite the significant engineering lift. Putting sensitive data in a separate data store in a zero-trust environment isolated from the rest of your application can significantly improve your security posture. Having a separate environment allows you to implement all of the previously discussed ideas, from fine-grained access controls, data encryption, reduction in risk via code change, and things we didn't talk about in detail such as monitoring and logging, into the secure environment. This separation of concerns helps you be more effective in understanding who is accessing your secure environment and how they're doing so. If your main application was under some kind of security breach, your separate infrastructure holding your sensitive data may not be impacted at all. And this is just to say that a separate environment may reduce the impact or reach of a data breach. Building this out can also simplify compliance regulations as well, because it enables you to enforce stricter security controls and audits to be confined to a smaller part of your infrastructure instead of the entire application. This is actually an increasingly common engineering effort in the industry and is becoming more widely known as a data privacy vault. Netflix, the streaming giant, has adopted a microservices architecture to isolate and secure different components of its infrastructure. By segmenting its network and implementing stricter firewall rules, Netflix has enhanced its security posture, making it much more difficult for attackers to compromise its systems and gain access to sensitive data. As we've seen through these real-world case studies, enhancing your organization's security posture can involve a significant amount of work and effort across various aspects of your infrastructure. Implementing all of these best practices requires time, resources, and continuous monitoring to ensure that sensitive data remains protected. However, there is an alternative solution that can help you offload the liability, the engineering work, and stress associated with securing your sensitive data. Skyflow's Data Privacy Vault offers a battle-tested solution designed to handle these challenges on your behalf. Skyflow is a zero-trust data privacy vault built to radically simplify how companies isolate, protect, and govern their customers' most sensitive data. Effortlessly meet GDPR, Schrems to BDSG, PCI, HIPAA, and data residency requirements with simplicity and flexibility, and eliminate PII data sprawl with Skyflow. And by leveraging Skyflow in your infrastructure, you can streamline your security efforts and enjoy greater peace of mind, knowing that your organization's sensitive data is being protected by a robust and tried and true system. Thank you so much for your time today. I hope you enjoyed this session. If you want to learn more, please come over to skyflow.com/get-demo today.